Welcome to Math. Mr. Jorgens here. We're going to be going over section 9.1 on simplifying radicals today. We're going to be going over this over a couple days, so I'll call this part 1. It's going to be all about square roots. If you heard of square roots before, radicals is another term for that. So stay tuned for learning, and there will be a few questions for you to answer along the way. All right, so we're going to start with an example 1 here, which is simplifying the square root of 24. And the way we're going to be simplifying these radicals is with what we call a tree diagram. And so what you're going to do when we go to simplify is you're going to think of two numbers that could multiply to 24. It doesn't matter which pair you pick. For instance, you could pick 6 times 4, or 12 times 2, or 8 times 3. It doesn't really matter. You can pick any combination. I'm going to pick 6 times 4. And then you're going to think of whether those numbers can break down or not. If the number is a prime number, that means it can't break down any further. But in this case, 6 is 3 times 2, and 4 is 2 times 2. So in this case here, we have a pair of 2's. And so what we do when we simplify radicals, this is a square root. So I'm going to circle my pair of 2's. And a pair is going to make a 2 on the outside of the radical. And then numbers that are left without a partner, like 3 and 2, there's no second 3 to pair it with. And there's no second 2 to pair that with. So we're left with 3 and 2 on the inside. So we're left with 2 square root of 6. So this is kind of the process that we're going to go through. We're going to break things down. We're going to look for pairs. And if there's any pairs, we can pull it to the outside. So let's try another one. This time we're going to try, I'll call this example 1b, simplifying the square root of 108. And 108 is a little bit tougher just in that you may not know right away two numbers that multiply up to 108. So that could make things a challenge for you if you can't think of that right away. Now, I know that 108 is 12 times 9, so I could use 12 times 9 right away, but you may not know that. Now, one thing you would know is that 108 is even. So if you ever got stuck, you could always go 108 divided by 2 because you know it's an even number, and then figure out what 2 would go into there. In this case, 2 would go into 54, right? And so I'm not going to use 12 and 9 because might not think of that right away. I'm going to use 2 and 54 because I think that's one that everybody could come up with. And then 54, hopefully we know that one is 6 times 9. And again, 2 can't go further because 2 is prime, but 6 and 9 are not prime. They can keep going. 6 is 2 times 3, and 9 is 3 times 3. And now we're at the end of the string, right? 2 and 3, those are all prime, so we can't break those down further. I'm only going to look at the numbers at the end of the branches. So 2's are at the end of the branches, and I have a pair of 2's, and I have a pair of 3's. So a pair of 2's means 1, 2 on the outside. A pair of 3's means 1, 3 on the outside. And then 1, 3 left over for the inside. 2 times 3 is 6, and then 3 on the inside of the square root there makes 6 square root of 3. So that's our general process for simplifying radicals. I'm going to have you try 2 of those on the next screen. So I'm going to have you try 2 here. The first one is going to be the square root of 75. So go ahead and simplify the square root of 75 and enter your answer when you're ready. So I broke down 75 in that way, 25 times 3. And then 25 could break down into 5 and 5. That leaves me with a pair of 5's and a single 3. So the pair of 5's would make a 5 on the outside. The single 3 would be left on the inside. Hopefully you selected 5 square root of 3. That's your answer there. A second one for you to try here. We're going to go ahead and do the square root of 180. So go ahead and try that one, square root of 180. Break down the tree and enter your answer when you're ready. So this one, at first I would have seen probably 18 times 10. 10 is 2 times 5, and then 2 and 5 won't go further. 18 is 9 times 2, and then 9 is 3 and 3. So I have a pair of 3's, a pair of 2's, and a single 5. And make sure like the 18, 10, 9 numbers, those are not at the end of branches, so those are not going to be included, right? And so my 2 and my 3 are going in the outside, and my 5 is going on the inside. So 2 times 3 on the outside makes 6, and on the inside we have square root 5, so 6 square root 5. Hopefully it was your answer on that one. All right, so the second thing we need to know how to do is simplifying when we have some x's on the inside. And so the way that's going to work is we're going to break it down in the same way with the tree. 9 is an easy number here, which is going to make up just a pair of 3's. Now the difference is I have to deal with that x to the third. And 3 times 3 is making 9. For the x's, x to the third is x times x times x. So I'm going to write it out as that string x times x times x. And what I have here is I have a pair of x's and one x left over. So I have a pair of 3's for the outside, I have a pair of x's for one x on the outside, and I have a solo x for the inside. So 3x square root of x would be my answer on this one. All right, so moving on to a second one, I'm going to have you try this one. It's very similar. We're going to do 36x to the third. So it should be very similar, except we have to think of the square root of 36 instead of the square root of 9. Go ahead and break that one down with the tree and enter your answer when you're ready. Hopefully we see 6 and 6 makes a pair of 6's for the outside. Again, 3 x's makes a pair of x's, 1 for the outside and 1 left over for the inside. So I'm left with 6x square root of x as my answer there. All right, so the last thing we have to talk about before you're ready to start the practice problems is dealing with fractions. So we have to be able to simplify this type of square root, something like this that has a fraction in it, like square root of 36 over 100. And the rule here is if we have the square root of a fraction, we can simplify that as the square root of the top over the square root of the bottom. So we could rewrite the square root of 36 over 100 as the square root of 36 over the square root of 100. Now, looking at this, square root of the top, square root of 36 makes 6, square root of 100 makes 10. And I kind of like this problem because both 36 and 100 kind of go in evenly as a square root. And then we're just left with 6 over 10. So not every time. I know in a couple of the past examples, we were always left with the square root part. But you will have some clean numbers like 100 where it's just 10 times 10, where that square root radical part can go away completely. Then once we're left with 6 over 10, we can reduce that to 3 over 5 as our answer. So sometimes they're going to kind of break down all the way. Other times they may not. So we may have something like simplifying the square root of 17 over 25. And so the rule is if I have the square root of a fraction, I can say it's the square root of the top divided by the square root of the bottom. Well, in this case, the square root of the top is just square root of 17. Square root of the bottom is 5. So I'm with the square root of 17 over 5. Square root of 17 doesn't go in evenly. And even if I try to do it as a tree, 17 is a prime number, so there's no way to kind of break that down. So I can't simplify the square root of 17 at all. And I'd just be left with the square root of 17 over 5 as my answer there. So I'm going to have you try a couple of those here. The first one I'm going to have you try is the square root of 4 over 36. So go ahead and give that one a shot. Simplify it using the rule we just learned. The square root of a fraction is equal to the square root of the numerator over the square root of the denominator. Simplify that out and enter your answer when you're ready. So hopefully you saw it as square root of 4 over square root of 36. Square root of 4 is 2. Square root of 36 is 6. And then I can reduce that fraction 2 6. I can divide top and bottom by 2, and I'm left with 1/3. So 2 6 is 1/3. Second part here, last one for you to try. I'm going to give you one that has a fraction in it. We're going to do the square root of 13 over 81x squared. So go ahead and work that one out and enter your answer when you're ready. So again, using our rule, I'd have square root of 13 over square root of 81x squared. 13 is a prime number, so I'm not going to be able to do anything with that part because it's only 13 times 1. 81x squared, though, 81 is 9 times 9, so a 9 comes out. X squared is x times x, so an x comes out, and there's nothing left inside, so I don't even have the radical part there anymore. Just have 9x, so I'd be left with square root of 13 over 9x. Some of them are going to simplify more than others, and that's okay. At this point, you should be ready to give part 1 of the big ideas a try, so go ahead and give that a shot and let me know if you have any questions.